Hello students, this is a program of selection sort. So let us begin. First we have the header file, we have stdio.h, then we come to the main function, and all the logics that are going to be used are incorporated in a single function, that is the main function. We are not going to go for any user defined functions. Okay, so firstly we have the array, and these are the elements we have 12, 45, 55 and so on. Then we calculate the size of the array, which is quite simple. We find the size of the entire memory allocation of all the elements divided by memory allocation of a single element, and by that we get the size of the array. Then we have certain variables with us. We are going to have I, j, a mean index and temporary variable. So these are going to be used in the future in this particular program. Then we also have a variable called count, which is going to count the number of times this for loop is going to run. As you can see, for each iteration the count value is going to be incremented. Okay, so now as we go inside this for loop, you can see this for loop is going to run from 0 to, in this particular case, 10 minus 1, which is 9. So less than 9 means 8. So it will go from 0 to 8. So if you count on your fingers, it is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it is going to run 9 times. Okay, so if we have 10 elements, then it is going to run 9 times. If we have 15 elements, it is going to run 14 times and so on. Okay, why it is done is because when you have 10 elements, if you sort the first 9 elements, then the last element is automatically going to get sorted. Okay, so keeping that concept in mind, we are going to run this particular loop for 8 times in this particular example. Okay, sorry, for 9 times, from 0 to 8, that is 9 times. Okay, so initially we are going to take the index value from this variable. So if you consider the first iteration, then we are going to put 0 here. Okay, so we are going to keep track of the minimum index. Okay, for initially the minimum index is going to be 0, because we still don't know what is the minimum value. So we consider that, okay, the first element is the first place is having the minimum value for now, but later on it may change. So what happens is, after we have initiated I is equal to 0, we go inside for loop. Okay, so this particular for loop is going to run for I plus 1, that is, if we take 0, then it is going to run from 1 up to the last element. Okay, because if it is 10, then it is going to run up to 9. Okay, so that means from 1 to 9 it is going to run. Why it happens? Please go through the video that I already gave you, where the concept, the theoretical part of selection sort was discussed. In that particular example, we found that if we have these particular elements, then what we do is we keep this particular element and we try to find the minimum of all the other elements. And if we find an element which is lesser than this particular value, then we are going to swap the two values, right? So the same concept is used here. It is just the application of that particular concept. So what happens is, if you consider the first iteration, then mean index belongs to this 12. Okay, and then we try to find the minimum value from 45 to 0. So in order to find the minimum value from 45 to 0, we are going to run this inner for loop. Okay, and once you find the minimum value, we are going to swap this 12 with the minimum value of the entire array. Okay, so how it is done? See, here we are going to consider from 45 up to 0 for this particular for loop, that is j is equal to I plus 1 up to j less than n. So whenever a new element is considered, and if this element is lesser than the particular element having index 0, then what happens is we consider the index of this new element having the minimum index. So what it means is, suppose you are going to compare this 45 with 12. Okay, suppose we have 12 and we have 45. So what happens here is we see whether 45 is lesser than 12 or not. Okay, if 45 is less than 12 or not. If it is so, then this minimum index will belong to the new one. Okay, but in this case it is not, because 45 is not less than 12. Okay, so we move on. We move on to the next particular loop where we are going to in this particular case. Okay, so we are going to go for 55, then 72, then 11. Suppose we consider 11. So here we know that 11, which is nothing but this array J. If this is 11, then we know that 11 is less than 12, right? This was 12 earlier, if you remember, because minimum index value was 0. So when this particular loop, this inner for loop went up to 11, it found that yes, 11 is lesser than 12. So what happens is this particular index of 11 will go to minimum index. Okay, so whatever the index of 11 is, it will be shifted to this variable called minimum index. Okay, so we move on and on. We try to see if we have more smaller values than that, and yes, we can find. If we go to 1, then yes, 1 is again lesser than 11. So if we consider this particular element called 1, and if we consider or if we compare it with a minimum index element, then we know that earlier 11 was the minimum, so 11 was compared here, and then 1 is here, but we know that 1 is lesser than 11, so the index value of 1 is going to be shifted to minimum index. So this goes on and on until the minimum value is found. So we already see or observe from the example that 0 is the minimum value, right? So if we consider all the iterations of this for loop, then in the end of the day, we will find that the index of 0 is going to get stored in minimum index. Is it fine? All right. So what do you do after that? So after that, we are going to swap the two values, because here you can see when we went through the iterations, we never changed the value of I, right? I was always fixed. I was nothing but 0, right? In the first iteration of this outer for loop, I was 0. So here what you do is you take array 0, that is 12 here, and then you swap it with 0 here, that is the element that has the minimum index. All right, so as we swap, what will happen if we swap it? 0 will come to the place of 12 and 12 will go to the place of 0. Okay, so this entire operations will happen for the first iteration of this outer for loop, and 0 will come to its correct position, because we already know that if 0 is the minimum value out of all the elements in the array, then 0 must be here. And yes, after the first iteration of the for loop, we have been able to shift 0 to the first place. Then the second for loop will run, and when the second for loop runs, you will find that this 1 comes to the correct value, that is, it should be here, right? 1 will come to its correct place. Then you will find that for the third for loop, this 11 will come to the third place, and so on. Okay, it will keep on happening. So what you can do is, if you want to actually check what happens after each of the for loop, then you can just put the printf statement here and see the current position of the elements once the loop is done. Okay, if you want to do that, you can always do, you just put a printf here and display all the elements of the array to see the present scenario of the entire for loop. Okay, so once you do the entire for loop, finally you will be able to arrange all the elements in the ascending order. And remember, you need not go for any comparison for the last element, because in fact, if you consider the last element, it's a single element. With whom will you compare with, right? There is no other element in the right hand side to compare with, and that's why we don't go for 10 iterations if we have 10 elements. Okay, we go for 10 minus 1 iterations, that is 9. All right, so, and I'm talking about this particular example. Since this example has an array having 10 elements, we are going to go for loop 9 times. Okay, not 10 times but 9 times. And finally, we can print the particular elements in the array and see whether our logic is correct or not. So let us do that as well. Let us clear the screen, and then GCC, then selection sort. Okay. Okay, so it has been compiled, and now we are going to run it. Yes, so once we run the program, we see that all the values are in the ascending order. We have 0, 1, 11, 12, 34, 45, 55, 72, 891 and 3224. We can easily verify that all the elements are in the ascending order. So once you get the code, you can go for other elements as well and check whether the logic still helps in sorting the elements or not. And lastly, you see the number of rounds is 9. We always calculated this, right? As I told you initially, we are going to keep track of how many for loops we are going to run, and you can see we have run this for loop 9 times because we have 10 elements. Okay, it is always the size minus 1 number of rounds that has to be run in order to obtain the result. I hope it is fine. Okay. In some of the references, that is blogs or books, you may find that this particular swap operation is done in a separate user-defined function. That is also fine. You just pass these values to a swap function and it will do it for you. And also you may find some examples where printing the elements is done in a separate user-defined function as well. Okay. So these two logics can be written in two separate user-defined functions as well. But yes, the result will be same. I hope you have understood this. If you have any doubts, please let me know. Thank you and all the best.